in was that what was on that warm-up yesterday is definitely going to be on the quiz. Obviously, I'm going to try to keep, Monday, have a few more of those, and what we're doing today. So these first two were put on here because you're going to need to be able to do this for what we're doing today, so I wanted to refresh your memory about it. Okay, so we are dividing coefficients, so 28 divided by 7 would be 4, and what are we doing with powers? We're subtracting powers, so this would be 4x to the third. Here, x's cancel. 6 divided by 3 is 2. Make sure you do not have an x on your answer. Here, I threw in a 0 power to see if you remembered what is anything raised to the 0 power. It's a 1, and because there's other stuff, I'm just going to cross through it. Now I need to do power to a power. I always want to do power to a power first. This is not 3 times 3, it's 3 squared, which gives me 27. Then I multiply powers here and I get x to the 12th. I'm going to slide the 9x over. Now it is a division problem. 27 divided by 9 is 3, and I subtract powers and get x to the 11th. Question on those three. Okay? All right, my hint for this is that you do a 1 by 3 box, a 1 by 3 box, and then because of this plus sign, after that, you're going to combine any terms that you can combine. Y'all, some of y'all probably realize you don't have to draw the box. Y'all, this is nothing more than a distribution problem. That's all it is. That's distribution, and you combine like terms. That's all it is. The boxes just help you keep everything organized, okay? So, make sure you're adding powers, okay? Make sure you're adding powers. So, in the first box, you should have had 15x cubed, because we're adding powers. In the second box, you should have had a positive 20x squared, because we're adding powers. In the last box, you should have had a negative 10x. Question on the first distribution. Okay, I'm just going to go ahead and bring my plus sign down. When I distribute here to the first term, I get 12x cubed. When I distribute to the second term, I get negative 42x squared. And when I distribute to the third term, I get a positive 54x. Question on that first step of distributing. Okay, I can combine like terms. So I can combine the 15x cubed and the 12x cubed. And remember, when we're combining like terms, we're not adding powers anymore. So I will get a 27x cubed. I can combine a positive 20x squared and a negative 42x squared and get negative 22x squared. And then I can combine a negative 10x and a positive 54x, and that gives me a positive 44x. How'd y'all do on that? Yeah? We've been distributing and combining terms before. It's just now we've got these variables on the outside, which means we've got to add powers. Okay? We good? Okay. The next thing I had on the overhead was this right here. And I said, can you do this? Can y'all do this? Okay, before we do it, is there another way I can write this that helps refresh my memory on how to do it? How do I write this? 2x plus 7 times 2x plus 7. That's what the square means. It means multiply it times itself. So y'all, now that it's written like this, you can see it's a 2 by 2 box. It's 2 by 2 box. So we put a 2x and a 7 here, and a 2x and a 7 here, and now we're multiplying. So I have 4x squared in the first box, then 14x, then 14x, then 49. We want to make sure that we combine like terms. When we combine like terms, we are not adding powers, Braylon and Jax. We get 4x squared. We combine here to get a positive 28x, and then we have a positive 49. Okay, I try to keep bringing this up. It will be on your quiz because y'all, most common mistake made by students. They just tell me that is 4x squared plus 49. Like you leave the whole middle term out. Got to write it twice and do a 2x2 box. And again, y'all, some of y'all are sharp enough, you can look at this right here and figure out what the answer is. Square the first one, get 4x squared, multiply these two together, get 14x, double it, 28x, square the last one. Some of y'all don't need the 2x2 box. It's okay if you don't, but got to make sure the middle terms in there. We good? Okie dokie. Okay, so we are factoring using the greatest common factor method. Y'all, we've got more factoring to do than this. We're going to be factoring what's called easy trinomials, hard trinomials, differences of squares, may even go into factoring 4 terms by grouping. So factoring is an extremely important unit, extremely important, okay? Okay, so factoring, what is factoring? Well, it's finding factors. Okay, what are factors? Expressions that multiply together. They give you an example. 2x and 3x are called factors. They're factors of 6x squared because I can multiply them together and get 6x squared. We've done the greatest common factor here. So greatest common factor is, it's the largest number that divides evenly into the other numbers. Largest number that divides evenly into another number. Okay? Very quickly, how do I do it? The first thing I do is I focus in on the smallest number and I check it to see if it's the greatest common factor. How do I check it? Well, I take the other numbers and divide by it. I get a decimal, so it can't be 12. Next thing I do is list all my factors of the smallest number. Well, I've got 6 times 2. I also have 4 times 3. I begin to check starting with the largest one first, hence greatest common factor. So if I tried the 6, I would do 16 divided by 6. Do I get a whole number? No, I don't. It can't be 6. I go to my next one, 4. Will 4 go into 16? Yes, it will. So 4 is my greatest common factor. Okay, so that's how we were doing that yesterday and this morning. Okay, new thing we learned, monomials, that's where these variables come into play. Okay, first of all, with the coefficients, we got to find the greatest common factor of the coefficients. Okay, that's what we did here. But then with the coefficients, we've got variables. Well, the first thing we've got to remember is, y'all, that variable has got to be in common. It's got to be in all the terms. If it is, I am picking the lowest exponent as my GCF. I am picking my lowest exponent as my GCF. So, you get to hear it from me one more time. 15 and 20, what is my greatest common factor between 15 and 20? It is 5. Do I have an x in both terms? And I need the lowest power, which would be x to the third. That is my greatest common factor. So that's where we're at right now. Okay, now what we're going to do is learn to factor, okay, some polynomials by the GCF method. The setup when you're done looks like this. Your greatest common factor will be on the outside, then there'll be a parentheses with terms inside. Okay, so that's kind of what the setup is going to look like for your answer. So after you write that, I just want to show you something real quick, but I want everybody to catch up. Okay, you do not need to write this. I just want you to watch. Okay? Okay, we know how to do this, right? Okay, what do we get when we do it? Okay. Okay, y'all. Going this way. With factoring, we're going back this way. So in other words, you guys have been given something like this, and you're like, I know how to do it, I just distribute it. Okay, now we're going to be given that and have to go backwards. This is factored form. This is standard form. We're going to go backwards. Okay, how do we do that? Well, think about this. What's the greatest common factor of those two terms? So 2. Well, look what's on the outside of that parenthesis. That's what we're getting ready to do. And this is just one factoring form. It's just one. We've got more to do. So we're used to going this way, multiplying. Now we're going to take it backwards and put it in factored form. And we're going to end up dividing. It should make sense. If you multiply to go this way, to go backwards, you're going to end up dividing. That's why you had number 1 and number 2 on your warm-up today. Because we're going to be doing that, okay? All right, so that's kind of what we're doing. Now, good news is they've got the steps here, okay? I am going to add to this, and I'm going to use boxes. Some of y'all are going to realize here very quickly, you don't have to use the boxes. I just like to use the boxes because it's a great connection for students, okay? So what we're going to do is, first thing we're going to do is find our greatest common factor. Okay, so here's my binomial. 6 and 18, what's my greatest common factor? It's 6. Do I have an x in both terms? Okay, so what's my GCF? X to the, okay, x to the second. Okay, so leave room, folks. Just kind of leave a little bit of space here. And because it's 2 terms, I'm going to set up 2 boxes. The original problem goes here, 6x squared, 18x to the 5th. I'm going to put my 6x squared, my GCF, on the outside. And now look what step 2 says. Divide your terms in the box. Divide them by the greatest common factor. So there's my greatest common factor. I'm going to divide by 6x squared. I'm going to divide by 6x squared. So 6 divided by 6 is? What happens to my x squareds? So all this is a 1. Okay? 18 divided by 6 is? Subtract powers and get x to the, okay? So let me kind of connect this for you again. Y'all, if you remember, we didn't have this. We set it up and found this as our answer. Notice now we're starting with the stuff in the box and we're filling in the outside. Okay? So what is the factored form? The greatest common factor goes on the outside of your parenthesis. You set up 1 parenthesis and you've got what you had on top after you divided. 1 plus 3x cubed. Factored form, standard form. Standard form, factored form. These are equivalent expressions, y'all. They're written in 2 different ways. Factored form, standard form. That's it. Okay? All right. So I'm going to come here and I'm going to set up 2 boxes. I'm going to put my terms in there. 15y cubed, 25y squared, and the first thing I'm going to do is find my greatest common factor. What's my greatest common factor? 5 what? 5y squared. That's correct. 5y squared. So that goes on the outside. And y'all, you can go ahead on over here and get your factored form set up. It's going to end up looking like this, but I need to know what goes in the parentheses. So the way I do that is I divide my terms by the greatest common factor. So I'm going to divide both of these by 5y squared. Okay? So here, 15 divided by 5 is 3. I subtract powers. I have 3y for that first term. Here, 25 divided by 5 is 5. What happens to the y squareds? So in the parenthesis, I have 3y plus 5. Factored form, standard form. Factored form, standard form. Easy enough? Okay, let's do us another one here. How many terms I have here? 3. So, I'm going to do 3 boxes. Let's pop those in. 9x cubed. Don't forget the negative. Negative 3x squared. Positive 27x. And I need my GCF. Need my GCF. What is it? 3 what? 3x. Smallest power is x, and it's in all 3. Okay, so 3x goes out here. Okay, now I'm going to let you guys, I know some of y'all have gone way ahead, but I'm going to let you guys see what you can get here. Okay, let's see what you got. The first term in the parentheses should be 3x squared. Then, notice here, when I'm dividing negative 3 divided by 3, y'all, that's a minus sign, because that would be a negative 1, and it'd be a negative 1x. The last one is a positive 9, and you should not have an x. There should not be an x. The x is canceled. So this is factored form right there. We good? All right, for these next two, I just want you to find my GCF for me, and then I'm going to let you do them on your own. But we want to make sure we get the greatest common factor right. So I want y'all to take 1 minute in both of these, see if you can figure out the greatest common factor first in both of them. Then I'm going to let you do those two on your own. Greatest common factor. Okay, what did y'all get for a greatest common factor in this first one? Okay, keep going. 7xy is the greatest common factor for that one. How about for this one? Anything else? Nope. There is not an x in the last term, and there's not a y in the first term. That one is nothing but 6. Okay, so I'm going to stop here and let you guys give this a shot without me. All right, so I'm going to divide all the terms by my GCF. So in both of them, I'm dividing by my GCF. Okay, when I divide here, I get a y. That's it. Y or 1y, doesn't matter. When I divide here, I get a 7x. So the factored form is GCF on the outside, in the parenthesis is a y plus 7x. Factored form, standard form. Factored form, standard form. Okay? All right, the next one. 6 goes on the outside of the parenthesis. When I divide here, I get 2x to the 5th. When I divide here, I get a positive 6x squared y. When I divide here, I get a negative 3y cubed. Notice it's 3 terms, and I've got signs. I've got addition and subtraction separating them. Factored form, standard form. How'd y'all do? Good? Okay. All right, folks, I'm just putting the title on this for the notes, so you don't need to do that. Okay, so here's your first one. Okay, we're going to factor this. Okay, so you guys said that the greatest common factor, I think, was 6x. Is that right? Okay. If you did boxes, it's great. I'm just going to come right up here. Okay, and I noticed some of y'all, I noticed some of y'all are doing it in your head. I'm fine with that. I get it. Okay, 6x goes on the outside of my factored form because y'all 6x is one of my factors. Okay, when I divide, I should get 6xy in the first slot minus 3y in the second slot plus 4. Y'all good? Okay. All right. All right. I am dividing all terms by 4y to the 4th. When I do that, the first slot is 2y to the 5th. The next slot is negative 7. The next slot is negative 5y. Factored form, standard form. We good? I heard Miss Batchick told somebody something. What'd I just say? Who's putting words in my mouth?
Well, she met somebody else. I met Miss Hughes. She told you to never talk to her again.
Okay. Y'all don't pop my name in there. Don't pop my name in there. All right, here we go. What did y'all find the greatest common factor to be here? Okay, 6 what? X to the 3rd, Y to the 2nd. 6 X to the 3rd power, Y to the 2nd power is the greatest common factor. All right, if I can get everybody's attention. We're dividing every term by the greatest common factor. So in the parentheses, in the first slot, we should have 3x squared y. In the second slot, we should have a positive 4y to the fifth. In the last slot, minus 9x to the fifth. Did y'all do it right?
Yeah.
I need everybody's attention. I want everybody to stop talking. Y'all, an example. It looks like the easiest problem you can have, and the first 4 tables I went to had it wrong. You got to just stay focused. First of all, y'all, coefficient-wise, yes, 1 is your GCF. But y'all, there's variables. N shows up in both. So N squared is your GCF. Now, if you have 1N squared, it's the same thing. So now will y'all stop talking? So now I'm going to divide both sides divide both terms by N squared. So when I do that, I get 2N in the first slot. Everything cancels in the second slot, but remember, y'all, if top and bottom cancel, that's not gone. What is it really? It's a 1. Y'all notice, there are 2 terms in the original, there's 2 terms in the parentheses. That's not a coincidence. If there's 3 terms in the original problem, there's going to be 3 terms in the parentheses. Okay? So here is your factored form. We good? Eight is your greatest common factor. Eight x squared minus 4x plus 5 goes in the parentheses. Hang on. How'd y'all do? What happened? Did you pull an x out?
I got it right.
We did 4 to 8.
Yeah, 8's the greatest. I'll